Okay, very good, Max.
Which of the following electron configurations of outer sublevels is most stable?
17 is B. B is correct.
Which element has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3p4? I said A. Each period in the periodic table corresponds to a C principal energy level.
20 is C.
Compared with the electronegativities of the elements on the left side of a period, the electronegativities of the elements on the right side of the same period tend to be A higher. Yeah. And which of the following sets are the charges given correctly for all the ions? Which of the following elements has the smallest atomic radius? A. Chlorine. Claire.
Or the electron configuration of plutonium and
All right, so very good. So you're going to want to study these 25. They'll be on the test with the 25 additional on Friday from the homework yesterday. So if you get the homework out, I'm come around and check that real quick while I have somebody read in the book on page 200 and energy and the ionic bond. So we're going to address here lattice energy. So let's go with, observed to determine bond strength. So what determines bond strength? All right, Sam?
The size of the ion.
You're close. Let's look at two things. Let's look at like, okay, we'll look at magnesium chloride, and we'll look at magnesium nitride. Now when you do this, the first thing you want to do is put the charges on the board too. I've just chosen the elements first. So I go over there and I find that magnesium is in what group? Is it in the first group? In the second group. So it's going to have 2 electrons on the outside that are going to want to be lost. So it's going to gain a 2 positive charge. Now what group is chlorine in? It's in the halogen group, or the 7th group, so it's want to gain 1 to get to 8. Remember that? So it's going to have a 1 negative charge. Now back to magnesium, it's going to have a 2 positive. And Annika, what's nitrogen going to have? Well, it's in the group with phosphorus. So the fluorine group has 1 negative. It means it wants to gain an electron to get to the noble gas, pseudo-noble gas configuration. In life, people want to earn money so they can be stable. That's the whole reason they want to do it. If they're not born that way, some people are born into wealth and they're noble. Other people are pseudo-noble. That is, they weren't born that way. And you can kind of tell it because they act a little bit crazy. If you've ever watched like Talladega Nights, it'd be a good example of that. Will Ferrell in that story he'd be a pseudo noble person because he wasn't born into that. You can kind of tell it with his behavior. Some of the things that he says in that story, he's kind of like showing his pseudoness. So chlorine has 1 negative. What's the nitrogen going to be, Annika? Oxygen would be 2 negative because it's in the second group. Our correction is in the third group from the right, and they're trying to get to 8, right? So if you have your noble gas configuration for neon has 8 around it, right? And then fluorine has 7. It wants to gain 1. And then you're going to see the same thing following with oxygen. It needs to gain 2. So how many do you think nitrogen wants to gain? So that's going to be 3 negative because it wants to gain 3. If you gain an electron, right, you're going to be negative. Why would you be negative, Annika? If you have the nitrogen's atomic number is 7, right? Its atomic number is 7 right here. So if you have nitrogen, and its atomic number is 7, and it has 5 electrons around it, right? We're saying it wants to gain 3. So it normally has 7 protons and 7 electrons. So if it gains 3 more electrons, that gives me 10 electrons. So I have 10 electrons compared to 7 protons. So that gives me an overall charge of 3 negative. That's what's happening here. Do you understand why it's 3 negative? Because you've gained 3 electrons. And the protons basically are not able to balance it out. You've got a greater number of electrons. So you're 3 negative. Does everybody see that? Okay, so now you have to balance this out. We talked about it yesterday. How you find the common denominator. Common denominator here is what? Between 2 positive and 1 negative, common denominator is 2. So you have to have another chlorine to balance this out. So you have a 2 negative here and a 2 positive here. Does everybody see that? So the formula is going to be MgCl2. So here we have a 2 and a 3, so the common denominator is going to be 6. So you have to add how many here? So you have to have 3 of these. And you have to have how many of these? You have to have a total of 2. So you have a 6 negative and your 6 positive. Everybody see that? So what's the formula going to be? All right, so the question is, between these 2 substances, which has the stronger bond? Is this stronger than this? So we have A or B. Which one's stronger? So you have to vote. Which one's stronger, A or B? Raise your hand. A, raise your hand for A. 1, 2, 3, 4, 5, 6, 7. So we have 7 A's. Raise your hand for B. 1, 2. Let's say 2 for B. Well, the answer is B. B is stronger. And the reason why it's stronger is because the charge has a greater charge. 3 negative is greater than 1 negative. So the bond is stronger. So you might want to write that down. You'll see it again. Naming. So when we're examining like humans, who changes the name, the man or the woman? Yeah, the woman typically changes her name, right? So in chemistry, what do you think is going to change their name? The cation or the anion? Raise your hand for the cation. The cation is the metal, right? So, and the anion is the non-metal. So which one do you think is going to change, the cation or the anion? Yeah, the anion. So the anion is going to change her name. The cation is typically written first like Mr. and Mrs. I don't know why it's so much like chemistry. It just is. So, I mean, you just kind of develop those relationships. It's easier to understand if you can kind of relate it to the world that you live in. So the non-metal, she's going to change her name. So if we look at just a simple one up here, like let's say table salt, NaCl. So sodium, and then you have chlorine, right? Those are the two elements that make up table salt sodium chloride. So what is this going to be called? When you take sodium and chlorine and you put them together? Yeah, I told you the answer. I didn't mean to. So this is called sodium. And the ine basically is changed to ide. So chlorine basically is a Cl2 molecule. It does, it's diatomic. It doesn't exist by itself. Oxygen as well. So if you had something like Na O, what's the formula for this going to be? Yeah, the formula, this is going to be 1 positive, this is 2 negative, so what's the formula going to be? Yeah, Na2O. So you want to get the formula right first. You write down the elements, make sure you have your formula right by balancing them, because they're all going to have 0 charge, remember that? So you have your sodium, and this is going to be like O2, so that would be oxygen. And what's this going to be changed to? Sodium oxide. That would be sodium oxide. Now, the elements over there, this corresponds, the ide rule corresponds to all the representative elements. So the main group, that is the 8 blocks, are families in the periodic table that are predictable. So the predictable elements get the easy naming, the ide. Now the transition elements are the ones over there in the green and the burgundy and the purple. You have to use what to name them? Anybody know? Anybody ever heard of George Foreman? He had his little George Foreman grill. Well, he had like 8 kids, and what did he name all of his 8 kids? George. He named all of his 8 kids George. They're all George. So how did he separate the Georges? Yeah, Roman numerals. He's like, you're the George the 1st, 2nd, 3rd, the 4th, the 5th. And we have to do that as well for the transition metals. Huh? They're all George. Yes. Well, he might have had some daughters too, but you can skip and still call him George. But he had a lot of Georges. He had like 8 of them. So let's look here for iron. Let's go to iron. I'll do chloride. All right, so we have 2 examples up here of iron reacting with chlorine, right? So you have to assess the substance. You don't know what it is until you do an analysis on it, whether it's iron 2 or iron 3. They'll have to tell you this based on experimental analysis. Is everybody clear? So you've done your experimental analysis. The Roman numeral 2 tells you what? It has a positive 2 charge. And what does the Roman numeral 3 tell you? It has a positive 3 charge. So what's the formula going to be for this one? Fe what? FeCl2. Because this is 1 negative and this is 1 negative. So you need 3 of the chlorines there. So what's this one going to be? 2 of the chlorines here. Yeah, FeCl3. All right, so the Roman numeral tells you what about the metal? What does the Roman numeral tell you about the metal? It tells you the charge. So that's what we want you to understand here. Without the Roman numeral, you wouldn't know what the charge is. That's how we designate the transition metals. Just like George Foreman, you would have no idea which son is which if he didn't have a second, third, or fourth on there, right? They're all George.